Welcome to example number 2. We have a hypothetical atom that has 3 energy levels: the ground state and levels 1 above it and 3 electron volts above the ground state. And we're asked to find the frequencies and wavelength of the spectral lines of this atom. What are the wavelengths that are absorbed by the atom when it's initially in ground state? And then we're asked to draw an energy level diagram showing all these possible transitions of emissions and absorption. So I think the first thing I'm going to do is actually kind of start with C and I guess draw the picture that we're going to get in the end. We're going to start off with that. So I'm going to draw different energy levels now. So along the y-axis is our energy, and then over here we're going to have, we'll just call this lowest state here, ground state. And then about one above this, maybe right here, is the 1 electron volt transition up here, and then 3 above it is the other one that goes up to 3 electron volts, roughly. So we'll just call this ground state or ground level, and this will be basically like 0 electron volts. And then above this will be 1 electron volts, and then 3 electron volts above ground state will be this third state out here. I mean, you could call this n equals 1, n equals 2, n equals 3, but I'm not even sure if that's the first, second, and third. We know this is a ground state, but we don't know that for sure. Anyhow, we'll go into the part C in a minute and draw these emissions as we kind of go through A and B here. Let's go now into part A now. We're looking for the frequencies and wavelengths of the spectral lines for this atom. So imagine that it can make transitions. That was an electron that is like right up here at the top state. Here's an electron at this excited state, and we want to know what are the different types of emissions that it could have. So this electron could make a transition from the 3 electron volt all the way down to 0 electron volts. That would be one transition. It could, and in this case, the energy loss would be 3 electron volts. We could also have a kind of a two-step transition where it goes from the 3 electron volts down to 1 electron volts. And in this transition, we have 2 electron volts lost here, but then the electron can make a further step from this one down to ground state. And in here, it would lose 1 electron volt. So those are all the different transitions that we can get. These are the emission transitions. All right. So now let's look at the wavelengths that we can get here. So let's say we're going from the 3 electron volts down to the ground state. So I'll just write this to ground. Let's do that first. That energy difference, the energy of the photon, is really the energy level difference between here and here, which is 3 electron volts. And from that, we could calculate the wavelength because we know that this is equal to hc over lambda. So the wavelength of this photon would be hc divided by this energy 3 electron volts. And hc, remember, is 1.24 times 10 to the power 3 electron volts times nanometers, if you use your constant sheet. And then this divided by 3 electron volts. You can see the electron volts will cancel out, and you'll get a wavelength of 413 nanometers. We'll just call that lambda 1 for this particular photon that is being emitted as this electron drops from this higher energy level 2 down to ground state. Now you could also calculate the frequency as well if you wanted to. You know that C equals F lambda. So F would be equal to C all over lambda. That's 3 times 10 to the power of 8 meters per second divided by 413 times 10 to the power negative 9 meters. And that gives you a frequency of 7.26 times 10 to the power of 14 hertz. So that's the frequency of that particular photon. Now we continue onwards. We can do then from the 3 electron volts down to 1 electron volt state, and we can use the same thing. So the energy of the photon will be now the difference between that, which is 2 electron volts, and then you could find the wavelength. And you'll see you'll get a wavelength of 620 nanometers and a frequency of 4.84 times 10 to the power 14. And lastly, we can also do from the 2 electron volts down to ground, and actually, sorry, 1 electron volt to the ground, and figure out that wavelength. And there you go. You have these wavelengths, 413 and this frequency, 620 nanometers is this wavelength, and there's that frequency, and then 1240 and then the last frequency. So 3 different lines that you should see. And that's what is kind of shown in this picture down below here, right here where you have 1240 and 620 and 414. And lastly, let's show the energy level diagram for all possible emission and absorption transitions. So we have shown the emission ones. Let's show the absorption ones. So you have an electron that is over here, and it can absorb a photon. It can absorb one that will pop it up to this 1 electron volt line, or it could absorb the right amount of energy to pop it up to this 3 electron volt. So these are the 2 absorption transitions. And that's it for example number 2.